Hello and welcome to our lesson 5-3, algebra lesson 5-3. Our functions in the past couple days. I know yesterday you guys worked on direct variation, so today we're going to take all of that and we're going to work it into slope intercept form. So let's go ahead and start off, as we always do, with our anticipatory set. And today we're going to talk about, because what else does Mr. Bear talk about? We're going to talk about football. Okay, so we're talking about you huddle up, you call play. Football is a series of plays. Each play, you try and get a certain amount of yards, and you keep going. But what football plays are, they are a set of instructions. So, football is a game where you take 11 people and you try to score at the end zone, which is 100 yards away from your end zone. So you're trying to make your way down the field while another team is trying to stop you. So in football, each time you want to get some yards, you call a play, which is a set of instructions. So when I played football, a few of the plays we had, one of the plays was called Pro 21 Lily Drag. Pro 21 Lily Drag. So we would all get together, all 11 of us, and the quarterback would come in and say Pro 21 Lily Drag on one, Pro 21 Lily Drag on one. And we knew what that meant. It gave us a set of instructions. So what we did, and I'll draw up what it actually looked like, was, let's say the football's right there. We had some linemen who would always line up at the same place. And then the receivers, pro meant that the tight end would be on the right side. And then because the tight end's there, that would mean two receivers would be out here and the F receiver would be out here. So that's what the pro formation looked like. In a certain way. Then the next part, 21, told these two people over here what they were doing. 21. They're running that pattern. So we knew what we were doing there. The next thing in the play was Lily. And Lily meant that the quarterback would go to the left because L means left. And finally, we had this last part, drag, which meant this receiver would run what we call a drag. So it was a set of instructions. It told us where we were going to be and what we were going to do. You can see the slight change was Con 21 Roger drag. So you can see that the set of instructions changes just a little, but you'll see that the play looks quite the same. So there's our football, our lineman. Since it's con, this time, con meant that the tight end would go on this side, meaning our receivers would be on this side. Another receiver would be over here. 21 meant that these receivers knew what to do again. Roger is a little different, but it meant something similar. The quarterback would go this way. And finally, drag would tell us that something different was going to happen. And that's very similar when we come to functions. Functions are a set of instructions that then you can graph. And that's what we're going to be looking at today. So let's go ahead and get to our standard for today. Now, there are a lot of standards that we talk about during this lesson. We're only going to write one of them down. We're just going to note what the other ones are. So the standard is F F-IF.C.7a. Yes, it's crazy and long and strange. And what it says is graph linear and quadratic functions and show intercepts maxima and minima. Okay, so that is our standard. Pretty short standard. There is also quite a few other standards that we touch on though. So over here, just go ahead and write also -SS. We're also looking at A-CED.A.2. We're also looking at F-IF.B.4. And finally, F-LE.A.2. So there's a lot of other standards that this material also touches on, but linear and quadratic functions. And we're going to focus today on linear functions. Okay, let's move along and get to our, which will be a lot of language of the discipline. Go ahead and write language of the discipline. And draw those lips icon right there. Okay, so now what we're going to do is we're going to go ahead and go over each of our language of discipline. The first one, now we know what functions are, or we should know what functions are. We should also understand, we've done this before last year, partially what we do during the year in 7th grade is talk about functions. So this is just going to get a little bit more complicated about those functions. So the first term we have is parent and a parent function is the simplest function with the same characteristics. So just like when we simplify a fraction, same thing here. A parent function is when you can get the simplest form of whatever function you're looking at. Now to get a little bit more specific, there's also a linear parent function. And a linear parent function is a function in this form. Y equals x, or the function of x equals x. Okay, so that's a linear parent function. It's a simple form. Then we have a linear equation. A linear equation is an equation that models a linear function. And what that means is that it must be linear. So if you have something like y equals 2x, yes, that is a linear equation. But what if we have something like y equals x squared? No, that would not be linear because that has a power in it. Same thing if we have something like y equals 2 to the power of x. Again, that is not a linear equation because it's using an exponent. Okay, let's get into our last two here. The next one is the y-intercept is the point on a graph where a line crosses the y-axis. Simple enough. Anytime you're looking at a graphed line, wherever that line crosses the y-axis, that is what is called the y-intercept. Okay, and then the last thing we're going to go ahead and write down is actually going to be input as well, our details. So I'm going to go ahead and draw the flower right here. And go to slope, intercept, form. Now if you look up here, that's the name of our lesson as well. So this is going to be important right here. The slope-intercept form is our set of instructions. Like the play in football, it is the set of instructions. So the slope-intercept form is a linear equation of a non-vertical line. So any linear equation cannot be a vertical a function. The way we write this is y equals mx plus b. Now write that down because that is very important. That is what we call slope-intercept form. It's very important to know what slope-intercept form is. This right here will always represent the slope. This right here will always represent the y-intercept. Using those two clues, understand the visual representation. Brings us to this visual part of the play. Right? It's a set of instructions. So just like this is going to be a set of instructions. Okay, so as an example, let's go ahead and get one example in here before we move on to some modeling. The example is y equals 2x plus 3. So if that was our equation, well, easy enough. We look right here, and the slope would be 2 over 1. That would mean the rise is 2, the run is 1. Up 2 over 1, up 2 over 1, up 2 over 1. And then right here, this tells us that the line crosses the y-axis at 3. So those are the two pieces of information we need to then create a graph. So I'm going to go ahead and switch on to a brand new piece of paper. And we're going to get into some modeling. All right, let's take a look at our modeling for today. There's quite a few different examples we're going to go over. And let's go ahead and figure out what the first thing we're going to be doing is, which is identifying slope and y-intercept. Identifying slope and y-intercept. So just identifying. Okay, so I'm going to go ahead and write down a sample question. What are the slope and y-intercept of y equals equation, which is already in slope-intercept form, luckily enough, and decide what is the slope and what is the y-intercept. So let's just go ahead and write that out. Y equals 5x minus 2. Okay, so we know, based on what we've already seen, which one is the slope and which one's the y-intercept. So right here we have the slope, and right here we have the y-intercept. So let's rewrite this so it's a little easier to see, because right now we have a minus in there, and remember, our slope-intercept form has a plus sign, so we need to make sure that we have that the same way, so we are accurately getting the answer. Y equals 5x, that's fine, plus negative 2. Now we can figure out what it is. So over here, we can say, okay, well, what is the slope? Well, the slope equals 5. Well, it's 5x, but the line is going to be 5. And you can also write that as 5 over 1. So the rise will be 5, the run will be 1, up 5 over 1. The y-intercept, not 2, negative 2. So the line will next one. That one's simple enough. It's just taking slope-intercept form and remembering which piece is the slope and which is the y-intercept. Now let's get into writing an equation in slope-intercept form. Writing an equation in slope-intercept form. So the question I'm going to write down for this one is, what is an equation of the line with slope of negative 4 over 5 and y-intercept of 7. So again, now we're going to take the word format. It already gives us the slope and the y-intercept. So all we need to do is use equals mx plus b. We need to remember where the slope and where the y-intercept is. And we see that we have the slope and we have the y-intercept. So what we need to do is we need to substitute. So we need to sub negative 4 over 5 for m, which is the slope, and 7 for b. So we're just going to go ahead and plug those in. Y stays the same, equals, we're substituting 4, oops, that's very blurry, I'm sorry about that. We're substituting negative 4/5 for m, so it's going to be negative 4/5 x plus, and then we're substituting 7 for b. And there we go. we've gotten our y-intercept, our slope-intercept form. Okay, next part. Now let's write an equation based off a graph. Write an equation from a graph. Graph right here for us to see what we're doing here. Okay, I'm just going to label, there's 2, there's 0, there's -2, there's -2 over here, and there's 2 over here. Okay, and now let's say we had a graph going through here, here. Okay, so let's say, I know it doesn't look all that straight, but oh well, it's supposed to be straight. Okay, so first thing we need to do is we need to find 2 points along this graph, because that's all we need. So we need to find 2 points on the line. So what 2 points can we find? Well, I can see one crosses right here. This point is 0, -2. And I see a point right here that I can see, which is 2, 2. Okay, so those are my 2 points, 0, 2. Oh, sorry, 0, -2. And I want to find the slope. So to find the slope, we need to think back to when we had our equation to find slope, our slope equation, which is y2 minus y1 over x2 minus x1. Doesn't matter which way we put it, but I'm going to go ahead and use this as my 2 and this is my 1. So y2 is 2 minus y1, which is -2. Then x2 is 2 minus x1 is 0. We simplify. 2 minus -2 is actually going to give me 4. 2 minus 0 is going to give me 2. And our slope is actually going to be 2. Okay, so we found the slope. Then we need to find the y-intercept. And y-intercept is the y when x equals 0. So I look over here, x is 0 right here. I can see where it crosses, I already have it. It's going to be -2. So I have my slope and I have my y-intercept. So slope-intercept form there we go, is y equals my slope 2x minus 2. Or I could say plus -2, but I can just leave it like that. I found my slope-intercept form, and I'm good to go. All right, just a few more. Let's go ahead and get to our next sample, our next modeling question, which now we've done one based off a graph, but what if we are just given, we are writing from 2 points. The question states, write an equation in slope-intercept form for a line that passes through the points 2, 1, and 5, -8. So we're going to write an equation for that. Now, based on those 2 points, I don't see a y-intercept is going to come. So let's go ahead and start with step 1. We'll write our steps in different color. So step 1 is going to be to find the slope. So that's easy enough to do. All we need is 2 points, and we have everything we need to find the slope. So remember, the slope equals y2 minus y1 over x2 minus x1. Doesn't matter which order I put them in. I'll use this as my 2 and this as my 1. So y2 equals -8 minus y1, which is 1, over x2, which is 5, minus x1, which is 2. That equals, I just simplify them, -x minus 1 will give me -9 over 5 minus 2 is 3. So -9 over 3 is actually going to give me -3. So I found my slope. Great. All right, I'm running out of paper, so I'm going to go ahead and move to a different piece of paper, and we're going to go ahead and move on to step 2. Okay, so we've done step 1. We've found our slope. Step 2 is going to be use slope and 1 point to find the y-intercept. So think about all the different pieces of information we have, and I'll actually go back to this so we can see it for a second. We have 2 different points, and now we have the slope, meaning the only thing we're missing is the y-intercept, meaning we can fill in everything and solve for the y-intercept. So let's go ahead and do that. We're going to use the slope-intercept form to solve for b. Because b in our slope-intercept form is the y-intercept. Okay, so let's go ahead and take a look at our slope-intercept form. Y equals mx plus b. And what information do we have? Well, we have points. We just need 1, so I'm going to use the easier one. I'm going to use 2, 1. So we have a point, and we have, which is -3. So let's just substitute everything we need. Well, what's the y value in our point? Which we have as -3, times x, we even know x, 2, meaning the only thing we don't know is b. So now we simply solve for b. So first of all, let's simplify. 1 equals -6 plus b. So let's add 6 here and add, will give us 7 equals b. Oh, so we found our y-intercept. Y-intercept equals 7. Now we have all the pieces we need. All we need to do next in step 3 form. -3. What is the y-intercept? Let's just plug all the information in. Y equals m, which is going to be our slope, x plus b, which is going to be our y-intercept. And look at that. We found our slope-intercept form. So all you need is bits and pieces of information you can solve for everything else. Okay, let's do one more. And this last one is going to be graphing a linear equation. Graphing a linear equation. Okay, so the question is, what is the graph of y equals? So we're going to need a graph. So we can do some work on this graph. This is my x and y. Zero in the middle there. Okay, so we have that information. And we have our slope-intercept form. So over here on the side, we'll start with step 1. So step 1, let's just do the simplest thing we can. Let's find the y-intercept. So the y-intercept equals what? Over here, it's -1. So what does that mean for the point? That means we are going to plot the point, because the y-intercept is when x is. And I'm going to plot that point, 0, -1. I have my y-intercept. Great. Step 2. Is going to be, we know the slope equals we move up to okay, so let's plot that next point. We go up 2 and over 1. There's my next point. And you know what? For good measure, plot another. There we go. All right, then let's go to step 3, which is the last step. Step 3 is simply to draw these 3 points. And there we go. We've graphed our line based off our slope-intercept form. So that's everything we need to go over. We've gone over, I believe there's 1, 2, 3, 4, 5 different examples of how to do this. So when you see any variation of this in the homework, just and you're finding the pieces of information for what you need. All right. Our guided practice. Our guided practice for today is in our books PPSE number 11 through 33 odd. Our independent practice is on our Pearson Success Net, and it is lesson 5-3 quiz. And that is assigned already. That's everything. Good luck, have fun, and go Buffs.